Alright class, let us now proceed to a linear power supply that uses IC as a voltage regulator, unlike a while ago that uses a discrete circuit with individual components. But there is a so-called disadvantages of this kind of power supply because the line regulation and the temperature stability are not optimal. But with the use of this IC, it increases the temperature stability. Then the overheating is also reduced because there is additional component here to perform such problem. Okay? The same with here, of course, this kind of IC 7805 is a fixed voltage regulator IC. 7805 meaning to say 78 is positive polarity because if it is 79, it is negative polarity, negative voltage. But since it is 78, positive polarity here, and 05 there is the output voltage which is 5 volts. Okay, we have here. This we are actually using here. Okay, let us try to measure using this DC voltmeter. We are now at DC. Okay, let us measure the output line here. Right across this capacitor. It is that capacitor. It is okay. The voltage here is 6.2 volts. Okay. 6.2 volts. The output. B. Let us read if this is 5 volts. Okay, let us try to change this IC with another IC which is 7812. Okay, let us try to change this IC with another IC here. This is okay. Okay, wait for a while. Instead of using 7805, we will change it to 7812. Okay. Now the IC is being replaced with 7812. Let us try to measure the voltage at the output. It is 12 volts. 12 volts because 7812 and it is positive output. This IC actually is a fixed voltage regulator. 7812 meaning to say positive 12 output. Probably the 7805 is a little bit defective already because instead of 6 volts, instead of 5 volts, it registers here 5 volts. This IC actually contains the complete circuit. It has also a series regulator, a comparator, a voltage reference, a feedback. Then there is extra component here to perform increase of temperature stability and voltage regulation. This is more efficient compared to the discrete circuit of regulator. Actually, this IC is called as monolithic IC because it can perform by itself without the extra components. For example, this is 9 volts. Okay? We have here the negative side, the positive side. It is 9.5 volts. if you have there the cellular phone, you need a charger which is 5 volts. You can actually reduce the voltage. We have here the input line, the ground, and the output line. The center is the ground. Okay, we have here the positive side. The ground is connected to the negative. It goes like this, class. Okay. Okay. The ground is connected to the negative side. The positive is connected to the positive side. Okay. Let us measure if how much is the voltage across ground, and this one here is the output line. 6.2 volts. 6.2. Okay. Let us read if this is 780. 780. Is this 7606? Or 7806? Or 7805? So, the output now is 6 volts. With single IC. We call it monolithic IC. Without extra components to be connected. This regulator is 1 ampere. Fixed voltage regulator. No? So, we can actually, if you wish to have 9 volts, so you can replace this with 7809 volts. 7805 for 5 volts. 7812 for 12 volts. Okay? This is now the monolithic IC that serves as a voltage regulator with fixed voltage regulator. It is a fixed voltage regulator. But there is another voltage regulator which is variable voltage regulator. So we have here. Okay. It goes like this. This circuit, class. The circuit uses this IC which is LM350. LM350 actually is a variable voltage regulator which is 3 amperes. The other lower current rate is this LM317 which is 1.5 amperes only. LM317 1.5 ampere, but it is still voltage regulator variable. The circuit goes like this, class. Okay, we have here a transformer with AC source. Then the secondary winding. Still we are using full wave with 2 diodes. Then we have here a supply filter capacitor. We have here. Okay, we will transfer this one here. Transfer. Okay. Okay. Then we have here a power indicator using light emitting diodes with series resistor of 680 ohms. Then we have here the IC, the input line, the output, and we have here the adjuster here. There is a resistor of 240 ohms. Then we have here the potentiometer. We have here. Okay. Then another capacitor here. We have here the output line. Unlike this one, in one, two, three. This is 7808. The in is here. The out is here. And this is the ground. So, it goes like this. In, the center is ground. This portion here is the output for the 7805 fixed voltage regulator. But with this kind of regulator, in, out, adjuster, meaning to say, this is LM317, class. In, the in is here, The out is here, and this is adjuster. So it goes like this, class. LM 350, LM 317. This is the in, this is the out, this is the adjuster. Because this terminal here is connected to the potentiometer. Okay, let us try. In what way that it becomes a voltage regulator which is variable. We can actually vary the voltage. Okay, we will use this transformer. We will use this transformer. The center is ground. It is connected here to the negative side. Then we have here to the rectifier diodes. Let us disconnect this one. LED. So that it is very clear for us to see the situation of the circuit. Okay? Then, let us measure the voltage at the output if it is really variable. Okay? We will use this one. Analog multimeter. It is set now to DC voltmeter. We are using 50 volts range. And try to measure the voltage at the output. Right at this portion here. This is the output line. We are connecting the voltmeter across that capacitor. Okay? Probably there are less loose contacts. Okay, the voltage here. $240 ohms. This is connected. Input, output is here. Okay, output is here. Then we have here the input line connected here. Okay, let us try to measure again. If there is really voltage changes at the output. Okay. The voltage now is varying. Okay, we have here. As you rotate the rotor shaft of this variable resistor or potentiometer, the voltage varies. Okay, we have here. It is 1.2 volts, the minimum, and the maximum is 14 volts. 14 volts. The maximum is 14 volts. We have here 14 volts. Okay? 14 volts. Then 1.2 volts. The advantage of using variable voltage regulator, which is linear power supply, is that you can set 1.3, 1.4, 1.5. You can set it to 3.7 volts, 3.8. Because the voltage actually at the output is variable. It can be varied from 1.2 to 14 volts using LM350, which is 3 amperes. You can use a bigger transformer, which is 3 amperes. But once the IC you are using here is LM317, and that is only 1.5 amperes, so it is better to use 2 amperes or 1 ampere. Or if there is 1.5 amperes transformer, is better. Okay? That is now, this IC actually is hybrid. Because it cannot operate without the other components. Without the resistor and this potentiometer, it cannot vary the voltage. So, this IC is called hybrid. Unlike the 7805 or 7812, which is a fixed voltage regulator, and it is monolithic. Because even without the other components, it can serve as a rectifier, as a regulator. Whereas this one, it cannot operate without this resistor, 240 ohms, and a potentiometer, which is 2 kilo ohms. So we call this one as hybrid voltage regulator, which is variable voltage regulator. Okay? So I think this is more preferable and more efficient because we can vary the voltage at the output. Okay? Unlike this one, which is fixed. If you want 12 volts, you have to use 7812. If you need 9 volts for the circuit amplifier, for example, we have to use 7809 or 7805 as a charger of your cellular phone. No? As a charger of your cellular phone. Just like this. This is a charger of cellular phone that provides 5 volts at the output. You can use this voltage regulator 7805 for your charger of your cellular phone. But remember, these are all linear power supply. By next meeting class, we will be discussing the switch mode power supply, which is the widely used type of power supply, the switch mode power supply, which is this one here, used by this cellular phone charger. Also with the TV receiver, this is actually a TV receiver circuit with power supply here, which is switch mode power supply. Widely used. Almost all electronic appliances use switch mode power supply. By next meeting, we will be discussing what is the difference between these two, linear and switch mode power supply, and which is more efficient. Is it linear power supply or switch mode power supply? And also we will be discussing the symptoms and their probable causes. We will come to the troubleshooting and testing of these ICs. The optocoupler, the switch mode transformer, this precision shunt regulator, and this control IC, also the MOSFET transistor. All of those will be discussed in detail. By this time, class, I will say goodbye and let us meet next time for the new topic, switch mode power supply. Okay, thank you very much for your attendance, class.